All right, hello once again, Jeff Scott of Rankin Technical College, and as part of my never-ending quest to make life easier for the Rankin Technical College AWD1000 Web Development Technologies and AWD1111 Database-Driven Web Development students, I've been going through and creating a series of video presentations based on the ebooks of Flavio Copes. I've done a set of presentations on 5 so far of his ebooks: HTML, CSS, JavaScript, ES5 to ESNext, and React. I'm in the middle of Node, and I'm going to do Express.js when I get done with this. So, jumping back then. We're on page 102 of 189, and we're talking about callbacks. As it says, you can't know when a user is going to click a button, so what you do is you define an event handler for the click event. This event handler accepts a function that will be called when the event is triggered. So for instance, let's just say that all you wanted to do right here was when the user clicked a button, you wanted a simple alert to come up that just said this button has been clicked. Then that alert would be the callback. So as mentioned there, typically a callback is a simple function that's passed as a value to another function. JavaScript is a bit unique in that it allows you to basically use functions and pass them and do things with them as though they're just variables. So this function will only be executed when the event happens. It says we can do this because JavaScript has first-class functions which can be assigned to variables and passed around to other functions, known as higher order functions. It's common to wrap all your code in a load listener event and then run it only when the page is ready. So we could do something like this. All right, callbacks, as it says, are used everywhere, not just in DOM events. One common example is the use of timers, and we've already seen this. All right. Now, XHR, which is an XML HTTP request object, also accepts a callback. It says in this example, by assigning a function to a property that will be called when a particular event occurs. So in this case, when the state of the request changes. All right. And what this is basically saying is, okay, if the ready state is 4, meaning that it's been completed, check the status. If the status is 200, meaning it was successful, then log out the response text. Otherwise, some kind of an error occurred. All right, and again, that will only happen when you are changing something. All right, so how do you handle errors and callbacks? As it says there, one very common strategy is to use what Node.js adopted. The first parameter in any callback function is the error object. So as you see right here. So if error is not equal null, meaning that what's going to happen is when you do this, you're either going to have data is going to be populated and error will be null, or error will be populated and data will be null. So if error has been populated, you're just going to log the error and return. If you get down to here, there weren't any errors, so you're just going to log the data. And as mentioned here, this is great for simple cases rather. But when you start adding levels of nesting, you can have a lot of callbacks. And this can start to become very complicated very quickly. All right. This example right here is 4 levels deep. So we've got here level 1. Inside of there, we've got level 2. Inside of there, we've got level 3, which is our timeout. And inside of there, we've got yet another level. And as the author mentions here, this is a simple 4 level of code, but it can be a lot more. And it says, how do we solve this? Well, just so you know, if you want more than I'm giving you, or if what I'm giving you makes little to no sense, what results as you get more and more into callbacks is what's called callback hell. And I can actually go out to callbackhell.com. It's a very simple site. That's it right here. And it doesn't link to anything else. It says asynchronous JavaScript or JavaScript that uses callbacks is hard to get right intuitively. A lot of code ends up looking like this. Now here we're I don't know how many levels, but we're more levels. It says, see the pyramid shape and all of these at the end. This is affectionately known as callback hell. The cause of callback hell is when people try to write JavaScript in a way where execution happens visually from top to bottom. All right, which might work in a lot of other languages, but it's not the best way of doing things in JavaScript. All right, callbacks, as it says, are just the name of a convention for using JavaScript functions. There isn't anything special. It's just a convention. Rather than immediately returning some result like most functions do, functions that use callbacks take some time to produce a result. The word asynchronous, or async for short, means take some time or happens in the future. Usually callbacks are only used when doing input-output operations. All right. When you call a normal function, you can use its return value. However, functions that are async and use callbacks don't return anything right away. So again, in this example, you've got to go out to the internet and find this. So as they mention here, in this case, the GIF might take a long time to download, depending on your network connection, etc. And you don't want your program to pause or block while waiting for it to finish. Rather, you store the code that should run after the download is complete in a function. That's the callback. The biggest hurdle, as it says, for people to understand with callbacks is understanding the order that things execute as a program runs. So the example here, it says, is meant to illustrate two important concepts. Number one, this callback is just a way to store some things to do at a later time. Number two, the order in which things happen does not go from top to bottom. It can jump around based on what is happening. Callback hell is caused by poor coding practices. Luckily, it says writing better code is not that hard. You need to follow 3 rules. Number 1, keep your code shallow. It says here is some messy browser's JavaScript that uses browser request to make an AJAX request to a server. The code has 2 anonymous functions. It says let's give them names. As you can see, naming functions is easy and you get immediate results. Number 1, it makes the code easier to read. Number 2, when exceptions happen, you get stack traces that's going to refer to the function name rather than just something anonymous where you've got to search through it. And number 3, it allows you to move functions and reference them by their names. So now you can take this, which is kind of a blob, and break it up into chunks. It says note that the function declarations here are defined at the bottom of the file, and that's okay because it's done using something that's referred to as function hoisting. All right, and if you want more on that, here's a GitHub article that they reference in here. Go back to here and let's finish this up. Number 2, modularize. It says this is the most important part. Anyone is capable of creating modules, also known as libraries. It says let's take out the boilerplate code from above and turn it into a module by splitting it up into a couple of files. All right, so it says here we've got a new file called formLoad uploader with the 2 functions that we looked at before. The module export bit, it says, is an example of what you do in Node. So I'm not going to really get into that right now. We've looked at that a little bit before. Now that we have this, we just need to require it and then we can use it. And we've done this before. We've gone through examples. If you remember, we did that before where we created the car class in one file, then exported it and imported it into our index.js or server.js, whatever it was we used class. It says now our application is only 2 lines of code with, again, following benefits: easier understandability and reusability. All right, finally, number 3, handle every single error. There are different types of errors. You know what syntax errors are. All right, typically they're caused, you did something wrong, and they're typically found by the system. Runtime errors, which again you cause, where the code will run, but you either got wrong results, or it locked up, or you got an exception. Platform errors, as it says, things like invalid file permissions, hardware drive failures, network connections. Now it says this section is only meant to address this last class of errors. The first 2 rules are primarily about making your code readable, but this one is about making your code stable. When dealing with callbacks, you are by definition dealing with tasks that get dispatched, go off and do something in the background, and then complete successfully, or they're resolved, or abort due to failure, which means they're rejected. Any experienced developer will tell you that you can never know when these errors are going to happen, so you have to plan on them happening. Now, I've given students this number before, and someone else could listen to this lecture and say that I don't know what I'm talking about. Okay, whatever. But I believe that well over 50% of code, at least back when I was a professional coder, professional programmer, probably a good 50% of the code that I wrote was defensive code. And I liken defensive code to car insurance. Everyone is supposed to have car insurance, just like everyone is supposed to write defensive code. But you hope you live your whole life and never need to use your car insurance. Just like you hope you live your whole life and your defensive code is never going to get hit. However, like car insurance, if you need it, you might need it bad. And in the same way, with your defensive code, if you need it, you might need it bad. So it says with callbacks, the most popular way to handle errors in the Node.js style is the Node.js style, where the first argument is always reserved for the error. And then you can check that first. And if there was an error, return. Do something with it. So having the first argument be the error is a simple convention that encourages you to remember to handle your errors. If it was the second argument, it says you could write code where you could ignore it. All right, code linters can also be configured to have you remember to handle errors. All right, so to summarize, the author says don't nest functions. Give all your functions names and place them at the top level of your program. Number 2, use function hoisting. And again, come back to here. It's that same GitHub example we talked about before. Number 3, handle every single error in every one of your callbacks. Number 4, create reusable functions and place them in a module. All right, splitting your code into small pieces like this will help you handle errors, write tests, and hopefully it'll help you develop faster. The most important aspect of avoiding callback hell is moving functions out of the way, so that the program's flow can be more easily understood by you and others. So this ends with giving you a couple of rules of thumb. Number 1, start by moving repeatedly used code into a function. Number 2, when your function or functions get big enough, move them into another file and expose them using module.exports. Number 3, if you have some code that can be used across multiple projects, as it says, give it its own README and publish it to GitHub. Number 4, a good module is small and focuses on one problem. Remember, a module is basically, it's like a function, all right? And in the same way with functions, they should be doing one thing, designed to do one thing. Same thing with a module. Number 5, individual files in a module should not be longer than 150 lines of JavaScript. And again, are there exceptions? Always. Number 6, a module shouldn't have more than one level of nested folders full of JavaScript files. If it does, it's probably doing too many things. Finally, number 7, ask more experienced coders to show you examples of good modules until you have a good idea of what it's like. All right? I think that's pretty good. So, the alternatives to callbacks, as they mentioned right there, are promises, and promises are relatively new, ES6, and some people think promises are too hard to understand, so they put what is typically referred to as some syntactic sugar on top of promises and called it async await. All right, so promises and async await. When I come back, we are going to talk promises.